software testing methodologies, software testing methodologies, software testing methodologies. Software testing methodologies, public question paper, video 2, that is second unit. Video 2 means second unit, public questions, question paper. Video 2 means second unit. Second unit, public questions. Now, what is meant by transaction flow testing? What is meant by the transaction flow testing techniques? Or transaction flow testing or transaction flow testing techniques. Now, here in transaction flow testing, first what is required is get the transaction flows first. Transaction flow testing, what is required first? Get the transaction flows required. So here complicated systems represented by transaction flows. Complicated systems represented by transaction flows. It can be mapped into programs. Mapped into the programs. The transactions are done in the design phase. Transactions are done in the design phase. Transaction flows are similar to control programs. Transaction flows are similar to control programs. The transactions in design phase. The transactions in design phase are done in step by step. The transactions in design phase are done in step by step, so that the problems may not arise. The transactions in design phase are done in step by step, so that the problems may not arise. Now, it may be consists of transaction flows. In transaction flow testing, okay, it consists of inspections, reviews, walkthroughs, inspections, reviews, and walkthroughs. Now, inspections. In inspections, here detect errors by reading code. Here in inspections, detect code by reading. Sorry, detecting errors by reading code. Detect errors by reading code. This is done by developers or programmers. This is done by the developers or programmers. Mostly inspections can be done by humans. Some of the examples are checking the syntax errors, comparing the code character with character, etc. Next, reviews. Reviews are used to check the document. Review means is used to check the document. The quality of document. The quality of document is given by removing the errors in the documents. If you remove the errors in the documents, then automatically quality is improved. Quality of document is improved. Here there may be reviewing, planning, reviewing, meeting, reviewing, scheduling, etc. What here is going to be taken is there may be review planning. Review planning is required. How you can plan the review? Then review meeting is required. Then review scheduling is required here in these reviews. Okay. Then next walkthroughs. Next one is walkthroughs. In conducting the walkthroughs, we should discuss different transaction types. So in conducting the walkthroughs, we should discuss different transaction types. It covers 98 to 99% of transactions. Discuss paths by function. It satisfies the specifications and the requirements. Next, number 2. Use system testing and achieve C1 and C2 problem. Next, select paths beyond C1 plus C. Select paths beyond C1 plus C. Select paths for troublesome transactions also. Then next, design test cases. That is the design test cases. Next, select the paths. Next one is select the paths. The buyer, the buyer agrees the selected test path. Okay, next, tell the designers which paths will be used for testing. But not the details of test cases. Don't tell about details of the test cases. Then next one is path selection. Select paths for system testing. It is based on functionality. Confirm based with designers. Sensitization. The simple paths are very easy to sensitize, that is 80 to 95%. But complex paths are difficult to sensitize. So we use the following methods to sensitize the complex paths. What are the different methods? Use patches. So you have to use about the patches. It is easy to take information that is patched from another system for sensitization. Okay. It is easy to take information that is patched from another system for sensitization, but use patches carefully to sensitize the box. Then mistune. Test a system with 5 to 10% inadequate resources. Test a system with 5 to 10% inadequate resources. Then break the rules. Transactions need databases. Transaction need databases. Here, a system database generator is used. System database generator is used, but bypass the database generator and use patches. So what you can do, you have to bypass the database generator and then use the patches. Use breakpoints. Put breakpoints at the branch points. Tell about the breakpoints. Instrumentation. Here counters are not useful because the same model can appear in many different fields. So you cannot use about the counters. Why we are not use the counter means the same model can appear in many different flows. In different flows, it can appear about the same model. So we need to trace all processing steps. So we need to trace all the processing steps. These traces are provided by the operating system. These traces are provided by the operating system. Next one is test databases. Test databases. Test database is required for transaction flow testing. So test database is required for transaction flow testing. Every tester and programmer designer, every tester and programmer, every tester and programmer designs his own unique database. Design his own unique database execution. The transaction flow testing can be automated. The transaction flow testing can be automated. More test cases are required. More test cases are required to achieve C1 plus C2. More test cases are required to achieve C1 plus C2. Describe the components of data flow model. Describe the components of the data flow model. The data flow model is based on the programs control program. The data flow model, the data flow describe the component next question. It is nothing but the next question. Describe the components of the data flow model. The data flow model is based on the programs control program. The data flow model is based on the program control program. It consists of links. It consists of links which are denoted by symbols D, K, U, C, P. D defined, K killed, U used, C computational use, P predicate use. The symbols are called link pairs. Is also called as a link pairs. The symbols are defined as small d defined object, small k killed object, small u used object, small c computation usage object, computation usage object. You have to computate. Then P predicate usage object, P small p predicate usage object. That is predicate means decision usage object. Components of the model. Here the modeling rules. Here are the modeling rules. Number one. For every statement there is a node. For every statement there is a node whose name or number is unique. Whose name or number is unique. Every node has at least one outlink and at least one inlink except entry and exit. Every node has at least one inlink and at least one outlink. Okay, except entry and exit node. The exit nodes do not have outlinks and entry node do not have inlinks. So here the most important point is the exit node do not have outlinks and the entry node do not have inlinks. Exit nodes are dummy nodes. Exit nodes are dummy nodes placed at the end. Similarly, entry nodes are dummy nodes placed at the entry. The weight of simple statement is given by sequential actions of data flow. The weight of simple statement. The weight of simple statement is given by sequential actions of data flow. Sequential actions of data flow. For example, a simple statement A equal to A plus B. A simple statement A equal to A plus B is weighted by CD or CKD for a variable A. Okay, CD means computational usage and the computational followed by defined. CKD, computational killed defined. Okay, predicate nodes are weighted by the P uses on every outlink. Predicate nodes are weighted by P uses on every outlink. Next question. Discuss the complexity of transaction flow representation. Discuss the complexity of transaction flow representation. Transaction flow representation, complexity. So here in this complexity, first we can see about how the transaction flow is represented. Okay, how the transaction flow is represented. Then you can see about how it's complex. A transaction flow is processed in terms of forms. Each form consists of several pages with records and fields in it. There is a terminal controller and remotely located central computer (CPU). First, we see about the transaction flow representation. Then we see what is the complexity in transaction flows actually. Complexity. Okay, there is a terminal controller and remotely located central computer CPU. The user given input to the terminal controller. Here, the terminal controller requests order from CPU and then processed. After processing, the terminal controller send output to CPU. If the output is invalid, a diagnostic node code is transmitted by CPU to the terminal computer. The terminal controller transmits the diagnostic code to the user to check the input. At the end, the user reviews the fill form received. That is a fill form. Next, here, this one, user begin is there, process D1. D1 either process or cancel. So request form from CPU, that is P1. P2 accept order from CPU. P3 process form. So now P4 means transmit page to terminal controller here. Now it can accept or it asks any more fields. If it accept input P5, then ask any more fields. No means transmit output to CPU. Now accept CPU confirmation. Now it's going to be transmit the diagnostic code to terminal. Okay, if it is valid, then ask about more pages. If it is invalid, then then again it's going to process, that is P7, P6. Then next, if more pages are required, yes, more pages are required, yes, it continue about B. So again it continue. So more pages is not required, then no means the user wants review. So yes, review, so provide review. Otherwise exit. See this here I have written about the in description. The above figure shows the processing of a transaction using forms. The decision D1 is used to determine whether to process or cancel the transaction. If the transaction is processed, then process P1, request order form from CPU. In process P2, the terminal controller accept order form from CPU and then process P3 and then process P3. In process P4, it transmit the page. To terminal controller. The decision D2 decides whether the form needs more fields or not. If it needs more fields, then it goes to process P5. Otherwise, in process P6, it transmit output to CPU. In process P7, accept CPU confirmation for output. The decision D3 decides whether the output is valid or invalid. If the output is invalid, then the CPU transmit the diagnostic code to the terminal controller in process P8. Then if the output is valid, then decision D4 checks whether the form needs more pages or not. If more pages are needed, then it goes to process P4, else it goes to decision D5. The decision D5 decides whether the user wants review or not. If review is needed, then the user set review in process P9. Otherwise, the exit operation is performed. Now, what are the different problems? That is the question now. What are the different? See here. Actually, complicated transaction flow. This complicated is nothing but the transactions have a unique identity. So the transactions have a unique identity from the time they are created and to the time they are complicated. So a transaction can give birth to others, and the transaction can also merge. So transaction flow model will be complicated. Transaction flow model will be complicated means why this transaction flow complicated? That is nothing but because it gives birth to others, and also it's going to be merged. Examples for transaction flow model to be complicated is births. Births is one decision. Decision means one incoming, two outgoing is called as a decision. Okay, one incoming, two outgoings is called decision. Then biases means one incoming, two outgoing. In this one is parent, second one is daughter. Metasis means one incoming, two outgoings. In this both are daughter. Parent is not there. Now next one is in figure A. The transaction will either take alternate one or alternate two, not both. This is known as a decision point of a transaction. The two transactions, alternate one and alternate two, has a different identity or same identity. In figure B, the parent transaction gives birth to two new transactions. In that, one transaction has the same identity as parent, and other transaction has different identity daughter. This is called biases. In figure C, the parent transaction gives birth to two new transactions. In that, two daughters have same or different identity, and the parent transaction is described. This is called metasis, merges. The two transactions are merged at a node, giving a new transaction with the same or different identity. Here, two paths are going to be merged and gives about continue. It is called as a junction. Here, two are going to be two flows are going to merge at one point. So predator and prey. So predator comes. Prey is going to be not there. Parent, daughter. So two parents, one daughter. Here, prey is going to be absorbed. Only predator is there. Predator, prey. So in this both prey is going to observe and predator only comes up here. Parent, here it comes about the daughter. This one complicated. In figure A, path 1 and path 2 merged a node and gives a new transaction to continue. Gives a new transaction to continue. Okay, this is called junction. In figure B, the predator transaction observes a prey. The prey is gone, but the predator retains its identity. This is called absorption. In figure C, the two parent transactions merge to form a new daughter. This is called conjugation. This is called about the conjugation. Okay. So solutions. What are the different solutions for these problems? That is, transaction flow model does not meet the requirements of a multi-process system. Therefore, a generic model Petri net is taken. Petri net use tokens. As long as test results are good, the imperfect model does not matter here. Okay. The following are some of the possible cases. Biases. The parent flow starts from beginning of a transaction flow to the end of a transaction flow. Take each daughter purchase a new flow. Mitosis. It starts from the parent flow to the mitosis point. From mitosis point, each daughter flow starts. Then next absorption, it starts from the predator flow to the absorption point. From absorption point, predator eats prey and predator flow starts. Conjugation. Here each parent flow starts from beginning to the conjugation point. From conjugation point, the resulting daughter flow starts. Births, mitosis, absorption, and conjugations are problematic for the software designers. Illegal births, wrongful deaths, and lost children are some of the common problems. Okay, some of the common problems. So next question is what are data flow anomalies? What are data flow anomalies? Write about data flow anomalies that may occur in a program. Next, data flow anomalies is an illogical or useless changes of state of data objects. For example, if the same object is defined more than once, then data flow anomaly occurs. Data flow anomalies is an illogical or useless changes of state of data objects. For example, if the same object is defined more than once, then data flow anomaly occurs. Consider A is C plus D. If A greater than 0, then X equal to 1, else X equal to minus 1. A equals 0, A equals 0, X equals 0. So by defining about these three gives about the data flow anomaly. Now A equal to B plus C. From the above example, we notice that the object is defined twice to 0, hence an anomaly occurs. An anomaly is denoted by a two-character sequence of actions. There are 9 possible two-letter combinations for DKU. They are They are DD. DD means it results a suspicious state. DD means defined, 2 times defined, not used. That's why it is called as a suspicious state. Defined and killed. So before use, it is not killed. Because of that reasons, it results a bug state. Defined and used, it is correct, normal situation. Killed means next defined, it is also normal situation. Killed. Once killed, it is okay. Next defined only. Again killed is not there. So it is a bug state. That's why it is a bug state. KU, it is also a bug state. Killed and used. Killed means after that defined is there. Defined is not here. That's why it is also a bug state. Used, defined. So used means next killed. Before defined, they should be killed. So it is a suspicious state. Used, killed. Okay, it is a normal situation. Used. Number of times you can use. It is normal situation. In addition to the above two-letter situations, there are 6 single-letter combinations or single-letter situations. K means minus K, that is possibly anomalous. Killed. D, normal case. Used, possibly anomalous. So K, not anomalous. Possibly anomalous. D, U, not anomalous. The single-letter situations do not give to clear data flow anomalies. Okay, because K killed means what is there before. So that is not there. So because of that reasons, it does not give the clear data flow anomaly. It does not give about the clear data flow anomaly. Next question. Write about static versus dynamic anomaly detection. Write about static versus dynamic anomaly detection. Static analysis is done at compile time. Static analysis is done at compile time and syntax errors are detected. Dynamic analysis is done at runtime. Example, dividing an integer is by 0. Static anomaly detection such as syntax errors are detected at compile time. It does not belong to testing, but it belongs to the language process. So static anomaly detection such as syntax errors, static anomaly detection such as syntax errors are detected at compile time. It does not belong to testing, but it belongs to the language processor. Dynamic anomaly detection is detected. Dynamic anomaly detection is detected at runtime with some of the data structures like arrays, pointers, and records, etc. It consists of dead variables. When a variable is dead in the program, then the problem is unsolvable. When a variable is dead in the program, then the problem is unsolvable. Second one is arrays. Arrays are problematic because the array is defined as a single object, but reference to specific locations within array is required. So array pointers are used to know whether the values are within the boundary or out of the boundary. Arrays are problematic, okay, because arrays are problematic. Arrays are problematic because the array is defined as a single object. The array is defined as a single object, but reference to specific locations within the array. Array pointers are used to know whether the values are within the boundary or out of the boundary. Within the boundary or out of the boundary. Next, records and pointers. Next one is records or pointers. In the case of records, files are created and the name of such files are dynamically known. Here we have the same problem like array problem with records and the pointers. Next, dynamic subroutine or function name in a call. A subroutine or function name is dynamically called. A subroutine or function name is dynamically called. Without executing the path, we cannot determine whether the call is correct or not. Next, false anomalies. Anomalies are specific to paths. That is, anomalies do not occur when the path is not completed. Such anomalies are called false anomalies. Anomalies are specific to paths. That is, anomalies do not occur when the path is not completed. Such anomalies are false anomalies. Then recoverable anomalies and alternate state graphs. The anomaly depends on the context, application, and semantics. Anomaly is recoverable on provided two anomaly state graphs. Seventh one, concurrency interrupt system issues. Anomalies become more complicated while moving from single processor environment to multi-processor environment. Anomalies become more complicated while moving from single processor environment to multi-processor environment. Much of integration and system testing depends on detecting data flow anomalies. Much of integration and system testing depends on detecting data flow anomalies. Explain about the next question. Explain about data flow state graph. Data flow anomaly state graph. The data flow anomaly defines an object to be in one of the following four different states. The states are KD. The states are the KDU, KDU. These states. Now here, capital K is known as undefined, killed, released. Different states. The states are KDUA. K means killed, undefined, released. D means capital D means defined, created, initiated. U means used for computation or in predicate usage. So computational usage or predicate usage. A means capital A means anomalous. Here U. So in used state, then it is U only. So from use to K, it is killed state. From K to A, it is used or K state. In A, it is in KUD. So from U, comes to the D state. From D, it goes to U state, or from K, it comes to the D state. How you can write here? How you can explain here? The capital letters K, D, U, A represents the state of the variable, and lowercase letters K, D, U represents the program action. The data flow anomaly starts from K state. The killed state K uses an undefined variable and killed. The killed state uses an the killed state uses an the killed state uses an undefined variable. The killed state uses an undefined variable and enter into A state anomalous state. So it goes to anomalous state. The killed state defines a variable in the killed state defines variable in D state, and enter into D. So from K it can enter either D, from K it can enter into anomalous. From K. Okay. So the K state, that is killed state, uses an undefined variable. Okay, undefined variable and killed. So it goes to anomalous. Undefined variable and killed, both. Undefined variable and killed is anomalous. Undefined variable U and killed, then it goes to the A state. Then defined, it goes to the defined state. Defined. So the the killed state defines a variable in defined state. If a variable again defined and killed from a defined state, then it becomes anomalous. If a variable again defined, when a variable again defined from D, again defined from D and killed, then it goes to the anomalous state. Defined from D state, again it is defined and killed, then it goes to the anomalous state A. Anomalous state A. A variable is used from defined state. A variable is used from a defined state. A variable is used in a defined state. A variable is used in a defined state and used defined state, and also used in U state and redefined in D state and redefined in D state. So defined and used, again it comes to the defined state. So defined, so used and again defined, used U and again defined D, and it enter into D state and enter into D state. So it goes to an anomalous state. After D state, it goes to anomalous state. So defined D state, used, it comes to the used state. Again defined D, it comes to the defined state. And defined state, defined and killed, it comes to the anomalous state A. The variable U is used in U state and gets killed in K state, and then used and killed from kill state K. So it goes to anomalous state. Okay. So the variable U is used in U state. The variable U is used in U state. One is over. Used in U state. One is over, and gets killed in K. 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 So it comes to the used and killed. So automatically enter into the anomalous state A. Automatically enters into the anomalous state A. Anomalous state A. So here most of the important questions, most of the previous questions we discussed here about the unit 2, about unit 2 previous questions we discussed. Okay. So next class, we see about the third unit, most important questions what given in the